All right, we're still going to deal with quadratics this lesson, just a little bit differently. Today we're introducing imaginary numbers. For these pages, there's going to be a lot of stuff that I just want you to write down, and then in class I'll explain better what it all means. So imaginary numbers, they occur when you're trying to take the square root of a negative number. If you notice in everything we've done so far, all of the square roots have been positive. So for example, if you were to type in, or I would like for you right now to type in the square root of -9 in your calculator and see what happens. Your calculator should tell you that it's impossible. It'll give you an error. So the way that we kind of went around that is by coming up with these imaginary numbers. As you look here, I is the square root of -1. So for example, for simplify the following radicals, the square root of -9. The way we do this is I see that I have a negative there. So the first thing I'm going to do is say, okay, so that's I square root of 9. By putting that I in there, that just gets rid of the negative. So that I's got to stay in my answer though. So now I can take the square root of 9, which we all know the square root of 9 is 3. So our answer is really just 3I. For the square root of -36. Again, I see this negative in here, so I'm going to pull that out front. So I have I square root of 36. And 36 is a perfect square. It's 6 and 6. So my answer is just 6I. 72 is not a perfect square, but again, there's an I or a negative in front of it. So I'm going to put I in front of the root. So I have I square root of 72. And then we have to see what perfect square does divide into 72. We should see that 36 times 2 is 72, and 36 breaks down into 6 and 6. So I circle my pairs, underline the leftovers. So my answer here is 6I square root 2. So again, if you're taking the square root of a negative number, you just replace that negative with an I in front. So if you see here, we have example 1, so we'll do this one together, and then this is actually the first try on your own problem. You're going to have 2 more try on your owns. I want you to find the solutions for the following quadratics, and we're actually going to do this by just solving. So I need to get x by itself. So the first thing I'm going to do is subtract 36 from both sides. And then I want to divide both sides by 4. So I should get that x squared equals -9. We know in solving that the opposite of an exponent is a square root. So the opposite of the exponent of 2 is a square root. So I take the square root of both sides. I'm left with x equals, and again, the square root of -9, I have that negative there, so I know I have an I. And we know that the square root of 9 is 3. So my answer is positive and negative 3I. Whenever you take the square root of something, I know that it could be a positive number or negative number as my answer. So now I want you to follow these same steps, but try your own for x squared plus 16 equals 0. Notice that we're adding 2 perfect squares. That's when we use the solving method. When we are adding 2 perfect squares. That's when you solve using your square root. Now that I introduced you imaginary numbers, we're going to talk about complex numbers. So expressions involving both real and imaginary pieces. The big thing that I want you guys to get out of here is we're always going to express the numbers in order. The real part goes first and the imaginary part goes after. So as I wrote up there, for instance, if I have 5I minus 7, this 5I is imaginary because it has the I with it, but the 7 is a real number. We've been dealing with numbers like this since kindergarten. So the big thing with complex numbers is I always want the real part to go first. So you would rewrite this as -7 plus 5I. So in this next thing you have to do, you need to make sure that all of your answers have the real part first and the imaginary part second. Because now what we're going to do is operations with complex numbers. So again, you see this -2 is real, and that 4i is imaginary. In this problem, I am adding these two complex numbers together. Just like with normal variables, we can only combine like terms. So I can only combine real numbers with real numbers and imaginary numbers with imaginary numbers. So I'm going to have -2 plus 3, and then I also have 4i minus 11i. When you're adding and subtracting, you can only combine like terms. So -2 plus 3 is 1, and 4i minus 11i is -7i. So again, these i's work just like x's do. They work just like any other letter or variable. For the second problem, this is actually a subtraction problem. So instead of adding all of my pieces together, I'm going to subtract. So again, my real parts are 4, and I'm subtracting 5 from it. My imaginary pieces, I have -i, and I'm subtracting an 8i. 4 minus 5 is -1. -1i minus 8i is -9i. Again, always having my real number in front of the imaginary number. So the three things that you guys need to know today is how to simplify roots with a negative underneath them, how to solve an equation that has a quadratic where you're adding two perfect squares, and then the last is adding and subtracting complex numbers. These are your two try your own problems. So have these two problems done, as well as the solving problem from a couple slides ago. Have those done for class next time I see you. Good luck.